I know a few of those names out there. So the idea of this Go Live is to introduce you into some of the concepts of SuperDuperDB and build something fun. It'll be a sort of starting point in the direction of building your own tools which you can run locally, and take full control over your AI stack and your software stack in general. Suffice to say that you've probably seen a lot about chatbots and building retrieval augmented generation. There's been a lot of talk about that, and that's just the first step. So being able to have a corpus of knowledge and to interact with it is just one thing you can do with your AI. And SuperDuperDB allows you to inject several wrinkles to that, which will add whole new dimensions to the types of AI apps that you're gonna be able to build. So I'm going to start in a Jupyter notebook, and then I'll create a sort of app later in the session. And what we're going to do is we're going to have some code hosted locally in the project directory, and we're going to make that first searchable. Then we're going to make it into something we can ask questions about, and then we're going to go deeper and extract interesting entities from that code and analyze them in a second step. And in the last step, we're going to take that whole process and essentially demonize it, so run it in real time. So if you're coding, then whenever there's a change, that whole process will in some sense be cleverly refreshed, so you can get interesting notifications and hints while you're coding or doing whatever you're doing. So you might apply this to another domain, but coding is what we all know and love, and actually create something useful and also configurable and controllable in a way that tools such as GitHub Copilot aren't necessarily, right? So this is a demo. It might not be, there may be other products out there like the one that we're going to create now, but the point is that this is just a starting point, and if you follow the patterns that we're presenting here, then you could basically, build a whole bunch of different things for yourself. So I'm going to use MongoDB in this, and I'm going to have SuperDuperDB installed. So you can look on our docs and on our GitHub to know how to install that. It's a simple pip install. I'm going to connect to a local MongoDB database which I've got running, and I'm going to get some data from the project directory in the form of code. Right, so the actual code we're going to analyze is SuperDuperDB code. So that's very meta. So you'll see in here actually the code of the SuperDuperDB project has been linked in here, and you see there's some .py files. So those .py files are going to become my data essentially, and that's just a starting point. We might, depending on how much time we have, and in follow-up sessions, actually cross-reference those with, for instance, the documentation. So there's so many things we could do here, but the first thing is to sort of connect the code with the database so that the models have a workspace in which to interact with the code. All right, so I've got a little snippet here, and I'm going to run that snippet to get all of the py files in that directory. All right, so I'm going to just run this. Okay, now you see that we've got essentially the files in the directory have been extracted into strings. Okay, so let's just see. So if I do that, I can see all of the .py files in the current directory. So if I do a for loop over those files, then I'm going to be able to essentially get the data from those files. So why don't we do that? So what I'm doing here is I'm going to, yes, we make sure we imported all of our packages. So these are the file names in this directory, and I'm going to do a for loop through these file names, and I'm going to load the file. So, and then we're going to get a dictionary here. Right, so we're going to get a list of data and put dictionaries into it. So open file as read mode, so we don't delete it, and then data.append, let's say content and file name. And I saw there was a double slash in there, so I'm just going to clean it up like that. Right, let's see if this thing works. Nope, of course not. First rules of demos is nothing works. Include, let's see. Ah, yes. Dot split. You have to split on the new line string. Alright. So let's filter out empty files here. Alright, so there we go. So now we have a nice data set. So let's have a look at it. Okay, that's not what we wanted. I believe it was this. Alright, so there we go. So now we have all of the Python files in the directory saved into a dictionary. So let's just verify that. So we can say next items, see what we've got. So so let's just take the first one. Right, and print r.content. So this is the first one, miss.files, and now we have a function here as a string in memory, or we have a module in memory as a string, and we're now good to go. So there we go, we've got a nice little data set. Let's just do a few little analytics. Let's see, how much data do we have? 160. All right, now what should we do now? How about we see, let's see the longest data in here. So max length of x dot content for x in data. All right, there we go. Oh, there's a biggie. Okay, so that's not so great. So what we could do is to essentially chunk these files so that we can more easily analyze them. So if we put very, very big files into LLM or an API service, it will break. So let's chunk these files. So I could either do this myself, or I could use a tool. So let's see if we can go on the internet and look for some tools. Llama index chunker. So what you'll see here is that SuperDuperDB integrates very nicely with other open source tools. So we could say do something like chunking using something like Llama index. So let's have a look what we've got here. Basic chunking. So this is where you really run into difficulties when you're trying to do things live. So actually what I'm going to do is I'm going to do some very basic chunking without Llama index. So we can just do that with a simple for loop. So here we're going to add an additional thing. We're going to open the thing and we're going to split it into lines. Right? And then we're going to say chunks equals text I to for I in range 0 to length of text in chunk size, chunk size gaps. We're going to chunk this thing. There we go. All right. Range 0 with the text. All right, there we go. Let's just check that that works. Content chunk. Okay, and then so the chunk size will be something like, you know, maybe 50, 100 lines, and then maybe we'll have a stride. But let's just do it without a stride so that we don't tie ourselves in knots too much. All right, so chunks is equals this. Data.extend. Yes, file and chunk. Yes, J4. J. All right. Oh, maybe we don't need that. Okay. We can do that. All right. So there we go. Let's see if that works. All right. There we go. For I chunk in enumerate chunks. All right. There we go. So now we should have better data. So let's have a look at our data. All right. So now we've got much more data. So how many data do we have? All right. So some of these files have been split into parts. One thing that we forgot to do was to join the chunk again. So let's do that. So we're going to join the chunk over the new lines. Oops. Okay, what did I do wrong? Let's see, chunk. Oh, chunks. Join chunks. Okay, any ideas on the chat? Someone might have an idea. Chunks 0. Yes, I didn't need that. So let's delete that. All right, so there we go. Data 0. All right, so there's a file name, and we've got that. All right, there's our data. Now we're just going to go ahead and we're going to insert this data into a database. So we can do that in SuperDuperDB with a simple insert command, and we should have that then. So there's our insert statement. It's a bit different from MongoDB. You actually have to execute the query, and there we go. So now we can see we've got the data in there. All right. Now we can apply some models to this thing. So let's now get a model and apply it. So I'm going to let's just add my key, okay, I have created an OpenAI key here, which anyone can use during a session. I'm going to delete it after the session. Right, so just full disclosure. All right, there it is. So we got that there. And now I'm gonna add that here. All right, so now I'm gonna embed these things. So let's do from superduperDB.extension.openai imports OpenAI embedding. All right, so this should allow us to embed these documents with the OpenAI API. You can use any embedding model with SuperDuperDB. This is easy because it's fairly cheap and quick, but there are actually better embedding methods out there. Yes, so let's go on here and look for a snippet that will allow us to do this, because I always forget, so I need to look it up in our own docs how to do this. So I'm going to go with text embedding adder 002, and let's see, so there's a model. Alright, so to check that this thing works, let's apply it to a single data point. That's with the predict method, and see if we can embed one of these things. Alright, so we've been able to embed this string here, this content. Let's now apply that same model, but apply it to the data in the database and store the outputs in the database. So let's say from SuperDuperDB import listener. So listener is going to be something you're going to be able to use later on to make your model essentially live on your data. So when you make changes in real time, you're going to be able to propagate those changes through to this code and run the model over your changes, right? And that's going to allow you to do cool things like build copilots. So let's see, equals. All right, so let's see if this works. Equals, so we're working with which collection? The SuperDuperDB collection. So we'll put that here, and then we're going to use the whole collection. But I could also put here, something like sub package or some kind of filter here. I could even do a regular expression with MongoDB, regex, file name, and then I could regex it somehow to apply to just a subset. Well, I'm just going to apply it to the whole lot. And let's see. All right, and I'll need the key. So the key is the actual field in the records I want to vectorize. That will be the content key. Okay, so let's see what happens. I have that object now. Now what I want to do, and let's also add a batch size. So is there a batch size here? If you want to know that, you can look at the API docs and click through to let's see, API. Okay, these things have the wrong names, which is good to know. Llama CPP. Here we go, here are the docs. So here we can work out if we have a batch size supported. So yeah, let's do batch size. Okay. Predict. So here I can add additional arguments to the listener to be passed on to the model when it's doing predictions in the database. So let's do that. Now let's apply this listener to the data we inserted. All right, so this is the second rule of something went wrong there. I see. Okay, I've got the wrong parameter. Let's do it without that one, see what happens. Alright, so now, bad request. Alright, so there are some messages in the, in the code which have some values which are not allowed by the OpenAI API. So we're going to have to escape those values. So since we're doing content-based search, it doesn't matter too much. So let's do some cleaning. So let's have a cleaner here and add the cleaner to the code. So re dot, let's see what the cleaner could be. Any ideas on the chat? Nope. So let's see, what can we do for a cleaner? Let's see. How about we just replace anything that's not a space, an underscore, a hyphen, or a space. Let's see what happens if we do that. Alright, so here I'm going to have to initialize this variable. Alright. We're going to replace them like this. Alright, and then we're going to put this thing in the brackets. Alright. Alright, so there you go. Let's see if that works. Make sure we import our modules. Alright, so let's see what the data looks like now. We have to actually append this thing. Data.extend temp. Alright, so let's see what we got. So we got some data. Okay, something went seriously wrong here. Any ideas? So let's just do this again, see what happens. Enumerate chunk. There we have a second join statement which has messed everything up. So now we have that. Alright, so now we can try the cleaning thing, see what we get. Well, that doesn't look like it worked because I still have this thing here. So let's just check the cleaner. We put cleaned here. Alright, so now we might be in business. There we go. Now it looks a little bit conservative, so why don't we change that for something a little less aggressive. Let's say, yeah, see what happens if we just escape those guys. So there's another. Anyone know what this means? S.input. Let's see. So now I have to do some debugging. There's obviously some kind of wrong input in here. Text. So that's text 0. So maybe we have the wrong model. So to check this and to debug it, we can use the actual model itself. So let's just do some investigating. So this is typical things that will happen, which is that your thing won't work like it says on the docs. So we need to actually work out what's going on. So let's try that. So at some point we should get to a data point where we're complaining. All right. All right, so let's see if we can do this. So under the hood, the listener is calling this and related functions. So this actually looks good. So there's something else going on. Let's have a look. So let's see what we've got here. So if we do predict batches on r.content on data to 10, let's see what happens. Maybe we can get the same error. Sorry. Yeah. Alright, so that works. So something else is not working under the hood here. So as a test, what I'm going to do is I'm going to import sentence transformers and see if it works with that. So let's import the sentence transformers code. This will show to you that you can drag and drop any different embedding models with SuperDuperDB. And we're going to take a snippet from the docs here and just copy. Yes. Maybe we'll take a slightly easier sentence transformer, smaller one. All right, here. All right. So now the difference here is that I'm hosting this locally on my client. So that's one of the key things. You can toggle between API versus local self-hosting, no additional coding overhead. Let's just check that this works. All right, that worked. So let's see if we can get this thing to do its magic. So I need to look for some kind of, okay, let's see if we can add a batch size here. I think 25 is a good batch size. All right, so now let's get this one going. Interesting. Okay, let's see if this thing has a batch size. No. m.predict keyword args. All right. So now let's apply this thing. Right, with any luck now, we're gonna actually get something that works. Okay, so we had 11 batches there, and now we've got something that's vectorized the data in the database. So let's just check one of these things. Okay, so here we have a document, and you see it has the vector in it of that document. So that's going to allow us to do vector search over the documents or the document chunks. And let's see if we can find something meaningful. So what I'm going to do this time is I'm going to wrap this. First I'm going to actually remove this one, because I want to wrap this with vector search as well. So let's first do that. Okay, so we now should have removed the outputs from the data. Let's just check this is all right. Okay, this didn't go so well. Let's see what happened here. This looks like it might be actually outputs from a previous model. So we should now actually manually drop that data. So let's just drop the outputs field. Update cannot be empty. What was that again? Ah, yes. So you have to remind me what an update looks like in MongoDB. So let's have a look here. So I have the query the wrong way around. So we're going to do this one like that, and then all right. Update cannot be empty. Alright, so it looks like we're going for /r variant, which is to delete everything and start again. Alright, so let's start again. We'll add the data. We're just debugging at the moment, so it's all in good faith. And let's start again. But this time we're going to wrap this with a vector index. Right, so one thing I didn't mention, there's a much easier path to getting a vector index, which is to call the toVectorIndex function. So m to vector index. So this time, not only will it create outputs, but also make those outputs searchable. So let's just check that we have the right inputs to this. Alright, and identifier, we're going to call it my index. Alright, so with any luck, this thing will now alright, let's see if this thing works. So we have a vector index now. So we convert the model to a vector index by applying the target of the data it should be vectorizing. Right, just to remind you, this is not just about vector search. We could turn the data into anything we wanted. So we have a listener in here like before. Oh, it's an indexing listener, sorry. There's an indexing listener in there. Does it have a predict ID? Yes, so this thing propagated through, and that's going to be the name of the outputs in the documents. Okay, so now let's apply this vector index. So applying anything in SuperDuperDB land means applying all the things inside those things as well. So that means saving the model, applying the vectors, the vector computations, and setting up a searchable index. Alright, so that didn't work. Right, so you see a lot of the same steps happening here. Okay, why did that not? Do we have actually data in our database? Let's just check. We do not. Okay, so let's actually add some data. Where did we add the data? Okay, we seem to have deleted the cell where we're adding the data. So let's put that here. All right. So this is interesting. So the OpenAI model is still saved in the system. So it's still trying to compute the outputs of that data come in. So what we want to do is drop all the models and start again essentially. So let's just drop the models. So I'm going to drop the models in the data and start again. All right. So there we go. We've got the data in there. Let's get rid of this stuff so that we don't get too confused. Right. So now, as before, we're gonna create a vector index, and now we're gonna apply it to the DB. So now it's vectorized code. Okay, let's try it without that. Alright, so now we've got vectors in the DB. So let's have a look at one of these documents. Alright, so the vectors are in there. Alright, so now we can construct a vector search query over those documents. And I'm going to put here the name of the field I want to search through. So that will be So I'm putting a short snippet which is describing the code I'm hoping to look for. So, and our index is called, what's it called? Let's look at the show function. So SuperDuperDB has versioning, and you can see in the you can see here in the list of what do we have. So we've got my index. So my index is the index name. So I can put here my index. All right. So there's a query. So let's see if we get code now which is relevant to vector search as a simple sanity check. Yes, so almost everything that we found in the top results is pertains to vector search. So let's see what happens if I change that to vector index. All right, so let's see what happens if I put actually a code snippet. Can it even do that? So the question is, how good is this model? Not great. So let's see. Okay, so I'm not super impressed with these results. The reason being that, you know, if this model were good, it would be able to distinguish between these basic concepts in the way it finds data from the database. So maybe it would make sense to try a different model. So what we could do now is we could set up a new model and just use that. So let's see, let's look on here, and there was a different model suggested. So this has been put together by our team, some useful snippets which you can just copy. Let's have a look here. So what about this one? All right, so let's try that one. So this is a much bigger model, so it'll take longer to download. Is text embedding 3 large, is that an OpenAI model? We could try that one. Okay, so let's see we can compare these things, right? So let's first let's call this my bigger index, right? So now we've got a new vector index. I'm going to apply. Okay, so that's kind of nice because you can just quickly try different things out by changing configurations, change the class, change the arguments, and at the end, I'll show you in a second, you'll have a record of all these things that you can easily export in a nice format. So let's have a look. So we've got now more vector indices, and there's more data in the records. So they're getting kind of big. I can tell you in a bit what we can do about that. So let's see what happens here. Still not great. To listen for incoming data. How about that? So what we want to do is get much better recall than we're getting here. Let's see what happens if we've got put 10 files in here. All right. So code to listen for incoming data. CDC listener. So it's reasonable, but it still won't get us to where we want to be. Let's have a look at, and this is a clear false positive, right? So this thing here is not going to actually not going to be anything to do with what we were looking for. So let's see if we can look at the content to kind of work out what's going on. All right. So maybe these chunks are too big. Timeout. So the problem with my query is perhaps that it's very, very generic. So how about we try load component from data layer? How about that? All right, so this is the right code in my opinion. So it's the data layer is the thing which controls, and we've got two chunks from there. So I reckon that if I were to use that as a basis for my next step, which is to pass this to the LLM, I might actually get somewhere. Let's have a look. So let's go down to the bottom. Maybe we'll reduce the size of this search, right? I'll just comment that. What happened there? There should only be 2 results. All right. Yeah, so that is great. So if we go to 1, then we should even just get okay. So not ideal. I think that if we print those out, the reason for why that happened will become clear. So what does it say? Load component, and I think there's actually a right. Exactly. So you have to realize that this finding next door neighbors thing with vector search, it's not as smart as sticking your text into an LLM, and it can't be as smart because it has to do much more in a shorter amount of time. So that's why it's just the first step to the next part, which is to pass this into your LLM. So I think 10 is a good amount. All right. So now we've done that, and now let's see, can we pass that onto an LLM in a way which is kind of smart and handy? So there's many different ways to do this in SuperDuperDB. I'm gonna show you a shortcut which you might not like, which is to just write your own class to do it. So maybe you won't want to use one of our components which can do this out of the box, but you would actually want to create your own model which can use the vector search to be another model essentially. So this is a RAG model. So here, for instance, I'm going to define my own predict function. Text, right? And I'm just going to return bananas. Right, so this is wrong. I don't know what I'm doing. Right, and the reason this is nice is because then you're not beholden to some package where you have to read through the documentation. When you're in Flow, you just want to get something done. Like I could go and read the llama index documentation or LangChain or whatever, but I could also just use my own thing. So test. Right. This thing needs some inputs, right? So my RAG model here. All right, so that's and there are some methods you get for free. So signature. You have to tell it what kind of what do the individual data points look like? Are they single things or do they come wrapped as args and keyword args? So that's what this thing's for, right? So so now I've got a RAG model which doesn't actually do anything even vaguely related to RAG. But what I'm going to do is I'm going to pass it a query template, essentially pass it some data which it's going to use to do the search. So for instance, here I could add this query into the body of the predict, right? and every component in SuperDuperDB comes equipped with a DB when you load it from the database. So let's see, question. I'm going to rename that argument to question, and I'm going to put the alright, and then these are also things which you could put as parameters. You always execute a query with just the execute method. It's a bit like IBIS, the package you might know, which we've been inspired by. And this is going to be called question. Right, so what I'm doing is I've set up a new model which uses, and I'm going to put these as parameters to, the index is a parameter, right? So string. Right, and let's put the n as a parameter as well to show off, right? So I don't actually need to write an init statement because this class here is a data class and everything downstream from it is a data class. Right, so let's see, return results. Content. Alright, so that's the beginning of the reg. And now okay, so let's just so the model is going to be called reg model, and let's add that data. So n equals 10 and the index is equal to my big index. So what was it called? Let's look in the system. My bigger index. Alright, so there's our reg model, and we can use the reg model now to ask us, so say, tell me about explain how a component works. Collection. We forgot to put the collection here. I think the collection was also a string. Right, so alright. Yes. So this is one thing you have to do in order to get a DB in there. You have to apply this model. So we're going to apply reg. Right, and now we have that. Okay, so basically what we've done now is we've we've now got our reg model, and it's registered with the system, but it doesn't do the reg thing. So let's add some logic to it, which makes sense. So what we could now do is use the OpenAI API and essentially pass these results here into that. So I always tie myself in knots when I want to use the OpenAI API, but there's this project called Light LLM, and this makes it really easy to call APIs. So let's see if we can copy one of these. So I'm going to pip install this model. I'm going to pip install this package. So there's all these different parameters you're supposed to pass to the OpenAI completions thing, and I would just prefer to have a simple function which I can call. So let's see if we can get this thing to work. Alright, let's put this thing here. It was in here somewhere. is. There's my OpenAI API. Alright, so let's put that in here. And now we can use that now to process our request. So let's put that. Let's see what happens if I run this thing. Alright, so that's great. So their package is broken too. Cannot import name. Okay, so I'll be interested in if anyone in the chat knows the easiest way to call an LLM. I would be interested to see what that is. Let's see if I did anything wrong here. Interesting. I'm guessing we might need to update our OpenAI installation, so let's try that. Okay, so we're probably going to have to restart the kernel. Luckily, all the data is still there in the database, and that's the great thing about having a database backing your system rather than having to start again. Alright, so let's fast forward back to here. Oops. Let's see if we can get this thing to work. Well, it looks a little more promising this time. Let's see what's the response here. Alright, so we get some text somehow wrapped up inside this model response object. So for some reason it comes out in this choices thing. No idea why, but yeah, that's how it is. So let's edit this thing and say maybe we can initialize this in the post init method later, but for now we're just going to use this function and the messages. So now we're going to define the messages. Alright, so what are the messages? So let's say prompt and then context. Right, so here we're going to build the messages, so we have to copy whatever it was that where's that thing gone? We have to copy this structure here. So content role user. Alright, so I guess everything has to have this user tag in order for this thing to work. So I'm going to say return. So let's see if I can pass each context as a single message. So let's say content prompt, and then I'm going to put the yes, and we want to add the question here as well. Yeah, content. For X in context. And then at the last part, I'm going to now also put a Q. Here's the question, and then I'm going to add the question here. Alright, so I don't know if this works. I can't remember if this is how it's supposed to work. But basically, what you're going to get is, say, info equals self.build messages from self.prompt r.contents for our results and question. Right, so now we've got our home-baked own RAG solution where we're just doing everything ourselves with the help of Light LLM. So alright, and then we're gonna say response equals this one. Alright, so that thing now is our predict method, and then I think we wanted to somehow get the text out of the response so we're not saving this object back in the database. So let's see. Alright. So let's see if this thing works. Alright, so that's the RAG model. Let's just get rid of some of these cells. Alright. Wonder what's happened to the connection. So somehow we've got a connection timeout. Let's just check everything's fine. So everything seems to be there. I wonder what's happened here. Okay, let's do this a different way. Like that. Let's see what happens now. We need to apply the right. So we want to add the prompt as a. So the prompt is important to tell the model how to act when new data comes in. So let's add the prompt here. So that's a very simple prompt. We can refine it later, but let's just start with that. Alright. So what's happened here? Prompt. So somehow I've forgotten to self.prompt. There we go. Bad request error. That looks like what we had earlier. Required parameter role. I see. So here we have to put the role. So that looks pretty good. So now we've actually now we're starting to get somewhere. So the response looks like this. All right. Okay, let's have a look. Let's see. R.message. Choices. So the choices, I seem to only get one choice, so I don't know why I'm getting that, but so this one, that one, choices, message, so dot content. So everything's kind of wrapped up in there, so I want to return that from my model. Right, so then I can actually use that with my database. Right, so now we've got that rag thing here. Right. So because of the size of the window that we're providing to this thing, self.in, this is taking a while. So let's see what R is. Oops. Yeah, so it gives us something similar to before. Now if we want to actually get something useful, this thing seems to be outputting markdown, it looks like. So we can display it as markdown. Oh, that's very nice. It's giving me a nice bullet pointed list. Components play a key role. Get component. So now I'm starting to get some love from this system. So now it's telling me things I didn't know, given that I don't know anything about SuperDuperDB. And this to me looks very accurate. So it's the data layer is the key class in our ontology, which communicates with the data backend and the database and so forth. And yeah, so our code is okay. So fine. So now let's see what happens now. This is where the magic's going to happen. I'm going to add an additional parameter, which is instead of having a single question, I'm going to have a search prompt and then a question I'm going to ask about the results from that search. So you'll see what I mean. So currently this model is using a question as a search and then posing that question to the LLM, right? But that's nice. So that will give me kind of content-based analysis of my code base. But what if I said instead, I'm going to change this one to search phrase, right? Search phrase, and the question will go there. So, and why is that useful? Because now I want to start using this thing to analyze my code base instead of simply, yeah. So let's see here. So if I do question is this, and then maybe I'll even, no, I'll do that later. So let's see what happens if I put search phrase here. So as a sanity check, let's just put the same thing we had before. Okay, broken. All right. No, don't tell me this thing has changed in any way. Okay, so now luckily we have Python, which has a debugger, so we can just go in there and see what this thing's saying. Okay, right. So the last thing was actually wrong. So what I meant to do was to put here response. Alright. Alright, so let's have a look. Yeah, so you get the thing. Now let's see. Code snippets with poor code quality. Alright, you see now the magics are starting to begin. Explain. What is poor? Is poor about these snippets. So this is now saying some very true things about my code, like so our code, sorry. Lack of documentation, and error handling is not done effectively, generic exception handling, lack of type annotations there, I'm not super complex logic, inconsistent naming. Alright, now that's great. But what would be even better is if we could somehow narrow that down to the actual code from which this thing stemmed. Well, the problem is that this this thing here is we've lost now the tracking. So now we're just saying something about some random snippets which provided. So what would be cool is if we could actually then now propagate the results now back into the database. So I'm going to stop now because it's already 1.5 hours. But what I would now do is I'm going to take this model here and compound that inside another model. So what I'm going to do is I'm going to say well, sorry, to be clearer, I'm going to take the query out of this model and pass the query to a listener, and then the listener is going to apply the LLM to the outputs of that query. So what I can do now is I say listener is equal to listener, right? And I'm going to say identify equals error finder or something like that, and then I'm gonna say my select is going to be this thing, right? And now I'm going to say model is going to be this LLM, so or a similar LLM. So this I would then actually change slightly. So I would then simply have, I would actually remove this content here and do this, right? Like this, right? So I'm not going to actually use the search phrase there. The search phrase is going to come in the listener. So, all right. So this I would say then LLM is equal to ragmol, and then essentially when I iterate this listener on the database, then the outputs of this model will be recommendations about code quality, and they'll be correlated with the file name, and if I had extracted the line number and so forth. And then finally at the end I can do things like I can start displaying desktop notifications and so forth. I had it earlier. Okay, so it's broken on my Mac, but basically you can easily, in Unix systems, push desktop notifications, and this whole thing can be run in real time, pushing useful messages into your consciousness. Yeah. All right. So the point is that this is like a very simple application of LLMs and RAG, with a wrinkle which I think is kind of hard to implement if you don't have the ability to use your model in these different ways, inside a listener, on its own, with a vector search inside the predict, or a vector search outside the predict in the listener, and so forth. And dependent on that, or consequent to that, that flexibility, you can build very flexible applications. And one feature which I'll just quickly show off just before we finish the session is this thing here, which we just programmed. It's kind of built on light LLM. It uses different models. If I do this now, right, and I think there was an additional requirement to get OpenAI with the latest version. So let's see what the latest version is. Okay, we can put this version here. Now this model, for instance, is something I can export to disk. For some reason it's huge, so I don't know why. There may be a problem with the not great. Okay, so let me just show you another way. So there are various ways to do this. Alright, not a good example. Let's take this one, for instance. So every model that you define in SuperDuperDB land is serializable regardless of whether you've I think there must be something big blocking up the system, so I'll just quickly let's just quickly show you just standalone here. Where is it gone? Yeah. Alright, so this model here, this is the first rule of demos, that something's going to happen. Something's going to happen as soon as you want to do anything. So what I think's actually happened is that the IPython interpreter may be blocking this. So let's see if I can do this in a IPython terminal. Alright, so let's see if I instantiate this thing, what happens. Alright, rag.encode. Oops. Interesting. Okay, so we've got a bug. That's not good. Okay, I'll show you an alternative way. There's always multiple ways to do these things. So if I add this into a module, right, alright, so now So what happened is that the model was trying to essentially serialize its own class inside the Jupyter Notebook, which is a notoriously buggy procedure. So often what is better is to write your class in a different file and then import that into your notebook. So here you see, okay, it's a shame I've dropped the system, so I don't have the other models. But here you see, we define this model ourselves, but it's actually portable. So now I can take this thing anywhere I like and reinstall the same model on a different system. And I'll show you how. So if I do this, so we have this document, this duality between documents and classes in SuperDuperDB, a bit like in Pydantic or data classes, but better. Well, let's hope this doesn't cause. Yeah, so here, right, so what's happened? I'm able to decode and encode my model from this format back to the original format with all of the parameters that I'd chosen, right? And that's very handy for portability. So I could even say rag.export, right? And then you see here, there's rag identifier is this thing, and in the my rag directory there is a component which has this content which we just alluded to, but we also have the requirements file which catalogs which requirements do I need to build this class, right? So of course you could do this manually, but the idea is to work quickly, iterate, break things, have bugs like we did. But at the end, once you're in this zone, then you're kind of home and dry, and you can easily transport this to other environments. Yeah, so I forgot to say hi, Jess. I wonder if you're still here, but good to see you. Anyway, so if there's any questions, I would love to hear them. Yeah, great. So I saw there was a suggestion to tell the specific codes which are buggy and to extract them. That's one way to do it. But another way is exactly to actually then reinsert this into the database so you have a structured catalog of what's wrong. Anyway, so thanks so much for turning up. If there aren't any more questions, I reckon that's enough for this evening.